Good morning, everyone. This is the session 4 from the playlist of rotational motion. The topic is the motion of center of mass, and I've written here a few important points. And before proceeding further, so the first important point here is that the center of mass of a system of n particles, which is existing in space, is given by x. This is equal to summation mixi, y is equal to summation of miyi, and z is equal to summation of mizi, where xi, yi, and zi, these are the distances of the individual particles along the x, y, and z axis from the origin, and mi, this is the mass of the this ith particle. So now if I combine these three coordinates in one equation, then I can write the equation as r is equal to x I cap plus y j cap plus z k cap, where I cap, z cap, I cap, j cap, and k cap, these are the unit vectors along the x, y, and z axis respectively, and r is what? It is the position vector of the center of mass. This is the position vector of the center of mass. So I have written this the position of the center of mass in the vector form by this equation. Now this equation can also be now written as the summation, that is mi ri divided by m. This is a capital M. Capital M is what? It is the mass of that system of particles, and where here ri is what? Ri is the position vector of the ith particle, and which can be written as x I cap, y I j cap, z I k cap, where I, j, and k cap, these are the unit vectors along the x, y, and z axis, and here xi is the distance of that this ith particle along the x-axis from the origin. Yi is the distance of that ith particle along the y-axis from the origin, and what is that zi? It is the distance of the ith particle along the z-axis from the origin. So I have written the position vector of any one, you can say, of any particle which is comprising that system of particles. So that is given by ri is equal to xi I plus yi j cap plus zi k cap. Now what I will be doing is I will be using this equation, and now this equation can be written as r into m. By cross multiplication, r into m will be equal to summation this equation can be written like this also, and if I differentiate this equation with respect to t, then what I will be getting? This will be equal to m dr upon dt, and this will be equal to m1 dr1 upon dt plus m2 dr2 upon dt, and so on. This will be equal to plus mn dr n upon dt. See, this equation you can also write this as m1 r1 plus m2 r2 plus m3 r3 and so on, plus mn rn. So this and if I so this is equal to rm. So if I differentiate this equation with respect to t, I will be getting this equation. Okay. So now now dr upon dt, this is what? this will be the this velocity of the center of mass. This is equal to m1 v1 plus m2 v2 and so on. This will be equal to m n vn. Here this v is the velocity of the center of mass, and v1 v2 and so on, these are the velocities of the individual particles. So again, if I differentiate this equation with respect to t, then what will we have? I will be getting this is equal to m dv upon dt. This will be equal to m1 dv1 upon d dt plus m2 dv2 upon dt and so on. This will be equal to mn dvn upon dt. So from this equation I can write that this m into, now dv upon dt is what? This will be the acceleration of the center of mass. This will be equal to m1, you can write that a1, m2 a2 plus m3 a3 plus this will be equal to mn an. Now here you can see here this m1 a1 is what? This is the force on the particle 1. Okay, what this m1 a1 is the force on the particle 1. This is the force on the particle 2. F2 is equal to m2 a2 and so on. We can write this this equation as ma, this is equal to f1 plus f2 plus f3 fn. So finally I have got this equation, and so MA, this is the which I have denoted it as F. This is equal to F1 plus F2 plus F3 okay. So from this equation we can see that the force acting at the center of mass is this sum of the forces acting on the individual particles. Okay, so this what is F? What is F? This is the force acting at the center of mass, and this is basically equal to the sum of the forces which are acting on the individual particles, which is comprising that system. So I hope you have understood what has been taught today. The most important relation which I wanted to derive here was this. That is, the force acting at the center of mass of any body is equal to the sum of the forces acting on each and every particle which is constituting that system of particles. So thank you very much for joining this session, and in the next session I will be coming up with a question which will be based on this topic. So till then, have a nice day. Bye.